We'll just wait for a few minutes and then start. Hello, good evening. Good evening. In the meantime, if you guys have any questions, you can ask. Okay, I guess we can start. So I'll recap few things from last time, and if you guys have any questions, feel free to um, stop me. Okay, so this is what we saw last time. Start from the beginning. Um, we saw the placement new operator. Okay, so essentially how to use the new keyword so that you can. I hope I'm audible and my screen is visible. Okay, uh, I'll continue, I guess. So using the new operator, you can allocate memory. So this is the C++ way of allocating buffers. The equivalent thing in C would be using malloc. Okay, and naturally you should also need to delete uh, this if you use news, right? So here we see a specific example of the placement new operator where you allocate a buffer, right? And because you use that buffer again repeatedly, so that's the essentially the new placement new operator. And this is something, this example will be the ordinary heap, okay, which gets deallocated. Like if you call it again and again, and you have to use delete. So because of the pre-allocation, um, calling this function again has less overheads. Essentially, that's the idea behind this placement new, right? Coming to the important concepts, so like reference. So we saw pointers before, right? So something like this, where you have some certain size, and here I have to define it as const because the size of stack allocated arrays cannot change. Okay, so this is a C style array, small a, okay, of type int, and using brackets when you define it such in this way with some size, right? So let's say I give 10. So you're allocating a specific size and you're saying this size won't change. Okay. Now the A itself is a variable, yes, but more specifically, it's actually a pointer. Okay. And that is the address of that stack. Okay. So we can actually do it this way also. You can just dereference that pointer, right? Store 7 in it. And if you try to print A and just like uh, use standard cout and just give it A is essentially the pointer pointing to the address to the starting of this stack. Okay, so you can print that address also, right? And it will print the address. Okay, and similar to how we uh, access data. So essentially, this bracket operation, okay, is a dereference operator. Dereferencing essentially as accessing the data contained in some address. So essentially, what it looks like is A is some pointer. You do a pointer arithmetic, as in I want to shift by some value I. Okay, I is in a loop, right? So it goes from 0 to some size. So size is 10 here. So from 0 to size, I'll have 10 values. When I goes from 0 to less than 10, right? So 9. So 0 to 9, so 10 values. So the way this operation works is it shifts by some amount, and the total number of bits or bytes, however you want to think, actually shifted is determined by the data type of A, which is integer here. So integer by default in most systems is 4 bytes. So this shift will be address of A, okay, plus I times 4, if I think of bytes. Okay. Now, important thing here, the data type of A itself, okay, it is size underscore T, which is the address that is possible, maximum possible address in your given system, wherever you're running this code. So this is a 64-bit system. So here it will be unsigned long int. Okay. So essentially it will be 64 bits. Okay. And unsigned because addressing will go from this no need to have negative numbers for addressing, right? You can always you should always start with 0 and go as maximum as possible, non-negative number. Okay. And the pointer A, okay. So this pointer or the star A, or the you can think of it like dereference also. I mean, again, dereference is more of a context thing. Here it is, I'm dereferencing it. Here, you might see another example where I declare pointers. Yeah, like something like this. So here it is more of a declaration. Again, in C++, the syntax of writing things are similar, but the meaning depends on the context. Okay, this is very important. Please don't get confused. Here, it means you're declaring a pointer. Okay, and here pointer with equals, this means dereference. Okay, it's the same star operator used, but the meaning changes with the context. Okay, here it's declaring the pointer n of data type integer. Okay, here it's you're accessing that pointer and storing some value. Okay, so here when I say pointer A, right, something like this here I'm using I'm referring to the data type A was declared with, usually some inbuilt data type like integer, double, float, custom, or you can have custom also data types which are not inbuilt, right? So like we're saying classes, you can have class pointers also, like objects which of data type, so your of data type whatever custom class you have made, that pointer. Okay, so you can have that also. Okay, so that is, so pointers are one way of accessing data in another memory, right? Um, one more way of accessing this data is using references, right? So we saw references last time. So we saw how to declare vectors. You can declare them by giving some size, or you can just resize them later. Okay, have some size and declare, right? So here I'm writing a function. Okay, so this function is returning a vector. Okay, and that's what I'm calling, I'm storing it in a. Now this return type is returned by value, as in whatever operation I'm doing here. Okay, let's look at the function. Inside the function, I declare a vector b of size whichever I'm passing here. Okay, then looping over that vector. Okay, going each element by element. Okay, then storing some value to it. Okay, that's essentially what I'm doing. Now I want to this function to return this b. Okay, so I just return b. Now the thing is, with this a, right, which is equal to this function size, and I pass some size. I define size as 10 and then pass that size variable to uh, func function, right? So when I say a equals to function, right? So this function returns return b. Now, important thing here, here the data type is standard vector integer. Okay, and b itself was like we saw last time, right? So b itself has only the scope of this function, right? So when you try to return anything, it returns the value, yes, but whatever data you stored here, it gets destroyed as soon as this function gets uh it finishes calling this function, because the scope of b is only till here. It's declared here, stored, and then returned here. That's it. So b, technically speaking, goes out of scope for this parenthesis, right? For these brackets. So now here you'll get a certain behavior of a, right? So we saw last time uh, the size of a really doesn't change. Okay, it's just still empty because you're returning an empty vector. The second way of doing it is passing a vector b, okay, pass by value, which we also saw here, passing a itself by declaring a size of it, and then you can work on it. Okay, but the difference between the previous example and like this example and this example is that you passed something called a, like this line, right? Line 26, you pass something called a, and let's say line 5 is also enabled. Okay, maybe I'll just enable them so that things are clear. Okay, so function A, you pass A, right? And then it takes some standard vector B. So this is passed by value again, but here it's a copy. So the data type is standard vector integer. Here we're passing A. So the function will create a copy B of all the same attributes as A, like size, and that's it. So things like that. So you can try printing B, or you can try overwriting or doing something to it. Like let's say here it was I hadn't stored any value to A, so I'll store some value to B. Again, the behavior is pretty similar to the this previous example we saw, because B is local again to this scope, right? So it again gets destroyed. So now this variable B, after it gets returned, okay, yeah, there is, I mean, you can, in this case, since it's void, I won't return it because there is no point in returning here. I'm just passing A, right? No. So think of this. So there's no return. But when I passed A, I created B. Okay. So a memory was again, a new memory was allocated of the size 10. Okay. So this will be required of size 10, same size as A. It was filled, but then as soon as function gets this function gets it's called done, B gets destroyed. So whatever value is stored anyway, it doesn't get copied back to A. Okay. So the way to get past A so that its value changes, one has to work with references. Okay. And this is not required. So what one can then do is pass A. Okay. But now this is acts as a reference. Again, we saw here the ampersand operator was meant to be an address. Again, it depends on the context. A lot of these operators and like star and ampersand, they have different meanings in different contexts. So one has to be careful while using them, and its meaning changes according to where it is actually used. So one has to be very careful with that. Here in this context, integer n is star n is like a pointer, and n itself is storing some address, right? So now because n can store an address and m is some variable, here I can access the address of m itself and store it in n. Okay. So here ampersand acts as an address operator, like getting the address. Here ampersand does not mean an address. It the what it means is it's a reference. In the sense, if I pass A and this function in its for its own context, like in its own scope, it will refer whatever is being passed as B, but A and B both are exactly the same thing. That's what a reference is. So according to reference, variables might be named differently in different contexts, like scopes. So like here in this scope, it is named A. Here in this scope of function, it is named B, but they're exactly the same data structure. Okay, so that's what a reference does. So if you compile this code and go to the actual addresses and all of the function, like look at the code, B and A will share the same address. Okay. Now, that is the main idea behind this ampersand here. Here in this context, this ampersand means a reference. Okay. Then, yeah. So if you try to run this loop where you are looping over the size of B, which is absolutely okay, because when you pass A and here it's a reference to B, this B is a reference to A, right? And A has its own size. So one can do a B dot size. It will work. Yes, it will have the size 10. You can fill the data and don't need to return or anything. Because it's already a reference. A has already been changed. Okay. I hope this idea is clear. This is an important concept of reference, similar to pointers, where you're trying to change data which is present in some other place or function. So main is, you can think like main is some function which has data structure A, okay, this standard vector A, and you're passing it to some other function for it to work, okay, and you want that data structure to change. So people either use pointers or references, okay. You can choose to use any of them. And yeah, that's I think more or less it. Then yeah, we just started when we see printing a how in each of these examples the output of a changes or not, right? So the return by value, the return, then the pass by value, where we're passing the parameters by value, and passing by reference. That's what we saw. Okay. Another important thing. So it's essentially the inline function. Uh, Inline functions are essentially used to reduce function call overheads, where if a function has a small body, okay, and we are going to call that function, let's say a lot of times. So instead of calling that function, one can actually place that uh, body in exactly the position where the function is called, right? So similar to what a macro does, but the C++ way of doing that will be using inline functions. Okay, so that's one. We also saw, I mean, we'll see this later, using const expressions to uh, get change code where you don't have to deal with the uh, macros like if defs, right? So yeah, right. So coming to a very important concept in C++, the object-oriented programming. So in object-oriented programming is like also C++ has classes, so you can do object-oriented programming. Essentially, like you have a class and then you make objects of it, right? So a class gives you a blueprint, a sort of a uh, I don't know. I mean, it's a template, but I don't mean the C++ template. More like a blueprint where it has some rules and a lot of different objects also follow the same rules, right? So we have as we saw before, we define something of a class called complex, right? With public variables, double and real, double like real and imaginary. Now we also define a function, okay, which is called norm. We'll name it as norm. And again, that will also have double data type, which returns the real times real plus imaginary times imaginary. Essentially, the distance from the origin for any complex number. Now, the good thing is, uh, if a complex number, right, which I've defined, I don't exactly need to know its real and imaginary calculated manually or anything. I can reuse this function for any object that I make, right? Any complex number I make. So, as an example, we see this C1, C2, C3, three complex numbers. Um, because I have made them public, real and imaginary, one can print the imaginary and real parts of each of these functions, right? The nice thing is I can just call norm and corresponding to each uh, object, it will print the norm because a class can access its own members, right? Okay. So these are member variables. A class can access its own member variables. Okay. Even if they are private. So if they're so here the variables are public. So I can access the members like real, okay, outside the class. So something like c1.real, I can do this. But if these variables are private, I won't be able to do this. But let's say this function itself was public, then it will return some value, which I can call outside the function, right? But then I do not even need to know the real and imaginary parts because they're private, let's say. But I can calculate its norm, right? I hope the distinction is clear. Then we also saw something of a class called line, which I construct using complex numbers. So uh, this is the complex number that we class that we had before. We also create another class called line, okay, which will okay, there's a question. Yeah, you can stop because I'm revising. So yeah, feel free to ask. Yeah.
Actually, can I? Are you a senior? Like, how can I address you?
Oh, it's fine. You can just call me Gaurav also. That's fine.
Okay, so there was a problem that I was looking into, and I had to work on a character of a 2D character array, and
Okay.
I was not able to point that the point of its address. Like, I wanted to swap the
Hmm.
elements of the 2D character array, and by assigning a pointer to the elements, like if the first row contains elephant and the second row contains tiger, and I
Okay.
point the zeroth element of the first row to one variable, and for another variable I point the zeroth element of the second row. But then when I wanted to swap it, then
Okay.
uh, like I was facing some issues. Like, I can't explain it now, or like I'm
Hmm.
not able to explain it now, but
Hmm.
I was stuck into it, and I couldn't
Sure. Sure.
find a way.
Okay. Okay. I see. If this is assignment questions, I'm not exactly allowed to discuss assignments, but maybe I can give you some hints as to where this is heading.
No, it was not an assignment question. It was
Sure. Sure.
a
It's okay.
question given to me by my teacher.
Sure. 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 That's okay. So essentially, what's happening is, so when you're dealing with arrays, right? So this is you're saying this is a 2D array.
Yes.
Okay. You can actually put the code in the chat for me to look. That's if that's okay.
Um, okay, wait a minute. I have to open my laptop for that.
Sure. Sure. That's fine. In the meantime, I can go ahead with the revision. That's okay. Yeah. All right. So continuing. So we saw line class, which I defined it to have two complex numbers, A and B. Okay. So here you can see that I'm using a class. Okay. Like I'm defining class, but I'm defining members with some data type of data type, which is itself a class. So classes themselves can be used as um, custom data type. You can think in this way also. Classes are a template, like a blueprint of a lot of stuff. Okay, you can think that way. So the stuff itself is member functions, member function, member variables. Okay, and they themselves can act as a custom data type for other classes. Okay, so as we see here. Now I define points P1 and P2, okay, which are complex numbers, okay, themselves. So complex data type, okay, this is the custom data type. Then a line 0 of line data type, right, which takes this P1 and P2 as these complex numbers to define it. Okay. Here, as okay, I should mention in both these cases, class uh, example and this line example and this, there is a default constructor, and we'll see constructor in the next code also. So there is a default constructor which I'm using here. I'm just assuming that the default constructor will take care of storing these values and all. Okay. Now, thing is, yeah. So the idea is that if I'm passing P1 and P2, which themselves are complex numbers, I'm expecting it to store A equals to P1 and B equals to P2 because that's the ordering in which these are defined. Okay. Now, I can further define more lines. Okay. So essentially, I'm making a square here. Okay. Which will have the four um, coordinates. So 0, 0, 1, 0, 0, 1, and 1, 1. But we'll have four line segments. Right. So those are the four lines I'm making here. So I'm passing 0, 0, 1, 0, and so on. As you can see, you can verify that this will form that square. Okay, in the 2D plane. Now, this is a simple example where you're saying how to define um, classes and more uh, and classes on top of classes, right? Right. Okay. I hope ideas still now are clear. Okay. Yes. And finally, we also saw important concept called constructor. Okay. And where you have a class which has, let's say, some private members, real and imaginary. Okay. So these are double. I'm defining them to be have as data type of double. And then you define something called a constructor. Okay. Which looks something like this. So you use the same class name and then you start an open or like close bracket. Okay. And this bracket itself can take inputs. Okay. So you can define to then to take double. So here I'm saying underscore real is the input it takes and underscore imaginary is the input it takes. Okay. And then separated by a colon. Okay. So these are then rest of the code, rest of the part of the code here till so the parenthesis is the body as usual. Okay. And before that, you can actually define what the class, the complex, like the constructor you want it to do. Okay. You can have more code here also. This is another way in which C++ allows you to define classes. Okay. So here, like in this example, I take no input. Okay. This complex doesn't take any input. It defines real to have real to be zero and imaginary to be zero. That's it. Okay. This is, you can write a constant like this. There's no, how do I put it? There is no rule against not that you can't write it like this. Um, but usually you like to write something like this. Okay, example, the one that I've commented here, where it's by default. If you don't pass some value, it is zero. So this is default parameters, right? And then I'm defining real, which is this real, the private member, right? To be underscore real, whatever value I'm passing to the constructor of well, when I say constructor, it's essentially when I'm declaring object of this class. Okay. So I pass values, real and imaginary, like two values, let's say, to the input while constructing this object. So the constructor gets called, it sets the value real to underscore real and imaginary to underscore imaginary. And then to check that the constructor was called in the body of the constructor, so which is within this brackets. Okay. So I just print something like standard cout constructor called for class complex. Okay. So that ensures that I call this class just to check, There's something called a destructor also for a class. You can define it, but or else you can just leave it like this. And yeah, so the syntax for it is you use a tilde operator, and then similarly the rest of the things. Okay. Like previously, we also have the norm function as the member function, and people asked about the getter and setter functions. So essentially, the idea is that here, because the member variables are private, I cannot directly change them. So to access those private members, you can write a getter function, right? So it returns the real part. So this, while this function is has to be complex, because if that is private, then you can't even call that function, right? So that function, let's say it's returns real, right? Now, essentially the idea is that there are some member variables which are private, and you want to get access to them. So this is the getter function. It I call it as get real. So it returns the real value. Okay, which is double. You can have a setter function also where there's this void data type, because whatever I want to set is what I'm saying as underscore real. Okay, and it sets real to underscore real. That's all. It's a setter function. Okay. And then correspondingly, you can define um, some code to check this, all these inputs and outputs. Okay, awesome. Any other questions other than The one which is asked, I can take them also. Okay, maybe then we can continue like for today. So yeah, let's look at yeah, today we can take look at static members. Okay, so essentially a static member is when you define a variable as static. Okay, so that variable, um, you can think of it like it is accessible by functions or let's say classes. We'll see some examples, but when they access that variable, it is shared. As in, let's say some uh, classes, like we have a class, but let's say we have two objects created out of it. When they change that variable, it's changed for the other object also. Okay. In terms of uh, without classes, just normal code also, when you define something as static, the memory allocation for it, right? It stays till start of the program till the end of the program. Okay. So let's see this static keyword in context of classes. Okay. So as usual, I will hash include stream, and then we'll define class called class itself. This probably is what I was using. Okay. Maybe I'll call it my class. Sure. Then let's define an integer. Okay, x, and let's define some functions. So I want them to be public so that I can call them. Let so it sets x equal to 15. Okay, so x is the internal member. Okay, so I should ask probably to the class. I define public here, but I have not defined anything for this variable. So I start my class. I just declare my x. Okay, and then start with public and then started a function. So can anybody tell me what is x? As in, is it what is the default behavior if you do not define it to be public or private? It's private, correct? That's correct. So remember in C++, the default behavior for defining member variables, right, or classes or functions is that it is by default private. Okay. So when we say something is private, it has the function or the object has its own copy of that member, and no other object can access that. Okay. When we say something is public, it has its own copy. Like all of the things are same. It has its own copy. Every object will have its own copy of that uh, member variable or function, and you can call those member variables or function outside the object also, outside the class in a way. Okay, that's the distinction. And today we'll say something called static. Okay, which is a member which is shared by all objects. Okay, all right. Let's write uh, another function print. So I'll put it like that plus 5. Then uh, let's print it. Just print it, call it x. and then enter number. Okay, so this is my class. I've defined my class. Then I'll define my main function where I'll call this class. I'll use this data type, okay, and call it O1, object 1, object 2. Okay, or maybe just A and B. So important thing here, like I said before, we have each object has distinct x. Okay, so let's say I call a dot get function, okay, and b dot get function. Now each of them will set x to 15, right? Now the thing is x, because they each own their own x, they'll each set the, x to 15, and then let's say I try to print a dot print and b2. So they both will give you what output?
15 and
Uh,
20, I guess.
yeah, that's correct. This is okay. Yeah. So it prints 20 twice. One from the x of A, one another from the x of B. Okay. Now let's look at another example. Okay. But this time what we'll do is just add a keyword called static. So something changed is I'm calling this x as static now. Okay. But one more change one has to make is this was like a declaration, but I have to now actually define that member now. So define this static member. You have to use the uh, class name as a namespace. Reminder again. So we covered namespace in the first class. Namespace is essentially you can think of it like giving uh, a name to a bunch of classes or functions or even variables. So namespace in a way is more uh, of a superset. One can think that way. I mean, these are all different things. Classes are different than classes themselves have something called members, which are variables. So variables are themselves something else. Okay. So a namespace is something which under which we define under which we can define classes. So I can have, so for example, if we see vectors, so standard is a namespace under which this class vector was defined, a templated class nonetheless. So this here is a template, but essentially under the standard namespace, which comes under the standard template library, that namespace has a class called vector, which has a lot of member functions like resize, like size, like capacity. So A is an object, right? Okay. And I'm accessing each of the member functions by doing a dot that function or passing that function, like calling that function and passing some value, like parameter to it, and so on. Okay. Very similar to that. I can define, sorry, I can define x, okay, to be 0. So here, in a way, I'm accessing this x using the name my class as the namespace. Okay. What this does is, because x is shared by all objects, it has to be defined. Then, yeah, yeah. So, mm, like I was saying, I'm using namespace my class to define x, and here it was declared. But the problem, the one thing to very important thing to remember is It has to be like not just declared but defined, so that in this case now it actually gets some memory allocated. Okay, yeah, it's project space. uh, I don't understand the thing. uh, Project space, what do you mean by that? As in, yeah, okay, okay, got it. So yeah, right. So it's yeah, essentially a namespace, right? Now the thing is, because we are trying to use this static now, it has to be actually defined. Like again, remember, static is shared by all objects, but it has to have some memory allocated, right? So we do that by declaring here, like this line essentially. Now, uh, not much changes need to be done for the code. Let's say I run the code. What do you guys think will happen? We didn't change much. We just added this static line here. What? Error. Okay. Why is that? Yes, okay. We would have got an error if I hadn't defined static, yes. But what if I do? Okay. Okay, static member can run without instantiating. Is that correct? Because I'll be accessing X here, right? So we can try it actually. We will get errors because you're trying to access X, right? Undefined symbol, because we're trying to access X here. So let's say we don't access them. We just define it, and then it's fine. Yeah. So the thing is, because we are trying to access X here, like get function, the print function also accesses X twice actually. I mean, this line and this line both, to print and to change its value. Memory needs to be allocated for X. That's what this line does. Okay. So in a way, yeah, you are right. If you have a static member, right, you don't actually need to instantiate if you're not using the function, using that variable or accessing it. But if you do, right, like this, then you'll get an error. Oh, right. So now let's look at the actual output. So let's keep it static, define all this, and instantiate it. Okay. Question is that error due to X recall only, right? As in, what I mean is, if you define static X and you try to access the value or print it or something, then it will throw an error if you don't do this. As in, just declaring X is fine. Yes. And you do not need to instantiate it if you're not going to use X. But if you're going to use X, like we saw, if I comment the body of get, the bodies of print, wherever X is, then this compiles perfectly and runs also. The reason for that is because I'm not touching X. I'm not using X as in calling it or accessing it or anything. Then if we do like here in this get uh, function, then we need to allocate memory. That's all. That's the idea. Because when you define something as static, memory doesn't get allocated for it. When you define just normally integer X, then either public or private. Okay. So public or private is more like distinction as to if that value or variable or function can be accessed outside or inside. So that's what just a public or private does. Other than that, any other um, yeah, sorry. So other than that, any other um, member or function which gets defined. So like integer X here, these functions themselves, all of them get memory allocated. Okay. As soon as you define a class, right? sorry, as soon as you define the class and call an object, all of this memory gets like allocated and instantiated. Okay. There will be a memory for integer x. Think of this example actually. There will be a there will be for object A, there will be memory allocated for x, its own get, its own print, everything else. Everything. For B, again, its own x, its own get, its own print, everything. Okay. Only when I define it as static, then they all share it, yes. But since I have not declared, I've not it's not any single object's job to allocate memory. Actually, that's how the language is written. So we manually declare it to like have not declared. We manually instantiate it so that next time whenever any object A or B, okay, they access X, they can access the memory. So it will have some value and whatever operation I want to do. Okay. Okay. So let's look at the output here. I hope this part is clear with how memory allocation, everything happens with classes, right? In general. Now, looking at the output, so X was defined to be 15. Okay. So that's what happens when you A dot get is called. Okay. Then B dot get also sets it to 15. That's fine. The same X, mind you. It's not the different X, it's the same X. Now, when you call print from A, it sets X plus 5. So 15 gets updated to 20 and then gets printed. So that's what. When you call B to print again, remember it's the same X. So new value for X is 20. 20 gets updated with by incremented by 5. Okay, and that gets printed. So 20, 25. To check, we can actually interchange the order of operations. Okay, and then see. I think we can guess the output here also. So it gets 20. You can convince yourself why is that happening. So A dot get sets X to 15, and then when you try to do print, it increments by 5. So and then prints it. So that gets 20. Then you call A B dot get. So it sets X again back to 15. Okay. And then when you call B dot print, it prints 15 plus 20, which is 20. Okay. So hence you get both to be 20. Okay. And this is the previous example where you get 20 and 25. There's a question, can you explain the execution flow? Okay. I mean, class should get execute first, right? Yes, that's correct. So in C++, things go from top to down. Yes. So first of all, the first line, it's a macro. There is a file called iostream. When you say hash include, essentially what happens is it takes that file, which is iostream, copies the whole content of it, pastes it in the first line. We just don't see it, but that's what happens. And then the question, so memory we assigned it after class. You kind of, yes, you do. Okay, I'll explain it one by one. So first is the taking the iostream file, the whole data of it. Okay, as in yeah. Okay, so the whole content of that file iostream, and you just copy paste inside iostream, as in the first line. Okay, that's all. That's what hash include does. The next is there is a class called there is a body. So from line 3 to 16, this gets compiled. There is essentially defines a class called my class. Okay, and then it just knows that there is a blueprint of integer x or static int x, whichever. It has a function void a void type get, which has this body. It has a function of print. Okay, which has this as a body. Both of them are void data type and public. Okay, it has all this blueprint. Okay, it now knows that there is a class called my class, which might get called. Okay, that's it might not even like possible that after that it never gets called also. That's okay. Now, now this is important. You have to um, allocate memory, yes, for this X. So then you define it. Now, thing is, the class needs to be defined first, then only you can do this. because defining it previously doesn't make any sense because the class itself is not defined. So the flow of execution is goes like this. And again, you have to define the class to even define the objects with the custom data type, right? So that's how that's the order. It always goes from top to down. Yeah. So that is the class should get exit. Yes, so that answers that question. And memory we assigned it after class. Yes, we have to assign memory after the class because X is otherwise not defined actually. Yeah. Okay. I hope this is clear. Any further questions?
Actually, Gaurav, I found the code, but the problem is I was just random guessing anything, and the snippet is this, which
Mhm.
I sent in chat, but I
Mhm.
have no idea how to swap the numbers. Like the question was, I had to use bubble sort to
Okay.
arrange the elements in ascending order of the character, sorry, string array. But I just don't have any idea how to access it. Like when I tried it, I was just blank. How could I access it and replace it with the last element?
Okay. Okay. So uh, let's look at the code.
In this code, I just defined an character search string array and just found the size of it, so it's of no use. But you can see the swap string function at the top. That
Right.
function does not use any pointer, and it just replaces it's just a normal swap function, because
Mhm.
our teacher told us not to use any predefined function. So I just defined a string function, but without the use of pointers, it just that it changes the function element, but it does not changes the actual array.
Does not change the actual array. Okay. So this is
Yes.
how to put it. This is another way you one accesses arrays. So to pass, you use the data type, then string, and then just give the brackets. So yeah, uh, right. So this swap function, you give two strings and then pass some n. There's a loop which says temporarily stores str1 and then just then you overwrite 2 to 1 and then temporary string. Okay. So what you are saying is the when you call swap string. Okay, I see main. Okay, so you have C1 to C all of them 0. Okay. And there is a while loop with increment.
Like
Uh,
this snippet was just a trial. So I was finding the size of the elements. Like the if I use size of function, it will give the size of the first row as 50. But I wanted to do it for 8. Like the elephant stands for 8 count, no. So I
hmm,
wanted to make the values of C1, C2, C3, and C4 as 8, 9, 10, and 6. So I
okay,
was just experimenting. The main problem is
I see. I see.
if I could ask you how to access the elements. So
Mhm.
how can we do that? And like basically swap it with using pointers, or we have to just make changes to the actual array.
Right, right. So yeah, actually the thing is, if you okay, maybe I can explain going back to 2D array. So essentially what happens is these are 2D arrays also in a way a single, you can think of like a flattened pointer. What I mean by that is, so character R, ARR, when I say ARR, ARR is an array. Okay. When I say an array, I mean the data structure list. Okay. So list is like a collection of contiguous data. Okay. The way to store, like access data structure is basically a C++ or C construct by which we access a list. Here it's specifically it's a character array. Okay. Now what I mean by this specifically here is the ARR is a pointer of data type character. Okay. Which has 50 times 4
Yes.
to 200 elements. that is the
Mm.
size allocated to it. Okay. Now,
Yes.
okay. And the way ND arrays are accessed in C or C++ is goes from right to left, as in 50 dimension goes first, and then uh, fourth dimension, as in the dimension which has four
Uh,
elements. The first dimension is
oh,
has 50 elements. Second dimension has four elements. That's the order of it. Okay, so to look at that, maybe I can. Yeah, there's a 2D array. Yes. So yeah, there is let's say I define an integer. So if you look at the screen, I define an integer a with 5 3, and this is a 2D array. This is a 1D array. This is a 3D array because three dimensions. To access this, you can do something like this. So aij, let's say I want to fill it with values. So let's say 5 times 3. So the total values are 15. I want to access from the uh, actually how it's stored in memory, or you can think of it like actually how the ordering will be. So I give the j as the smallest index. Okay, that's the fastest index. Then give the next index and so on. The way to look at, so then I multiply by 3. Now you might ask why 3? Now that because that is the maximum size of j. So there is a simple rule. I probably wrote it later somewhere. Yeah, something like this. So let's say I define a standard vector of standard vector. Is here you can also think like it's very similar to 2D array, but essentially it looks like, so let's say you have three indices to access a 3D array. Like C, I think probably okay, it's a vector, but anyway, you can think here it is like a 3D array to access uh, the elements in a linear fashion. You can do this way actually. So kth index, then jth index is the next fastest, then ith index is the next fastest, so on. Okay. To make them correct sizes, then you multiply with size of k, whatever is the size of k. Here I'm just as an example, I just wrote s of k to say this is the size of k, like whatever the maximum size of k will be, times plus I times size of the whole thing. So as in size of k, okay, that will be the times size of j, and so on. You can extend this to any NDRA. Okay. So now using sort of similar idea, you can think like you can actually access every character in that array, that ARR. Okay. So E will be some position, L will be some position, and so on. Chocolate also will have some position. You can do it multiple ways. One way is to say if you encounter a comma, right, that marks your end of your character. I hope this is little clear. As in what I'm
yes,
saying
yes.
is, yeah, as in what I'm saying is, yes, it is stored in a 2D array, 4 by 50, like as in 50 is the fastest, so 50 by 4 element. But every data structure, whatever ND array you think of, is actually stored as a flattened array. So now I can think of the whole thing as a flattened array and then access each element by some index. Okay, so the maximum, let's say,
So then if we access the element as uh 1 and 52, then it would go to chocolate. Like, is it so?
depends. I mean, I haven't counted, but yeah, something like that. Or you can actually do, you can try this for yourself. So take ARR as, mm, no, not this. Yeah, you can do it maybe this way also. So ARR plus some pointer and then dereference it. So that will access the ith value, like ith value, I mean, as an ith pointer, and we're dereferencing. So that value, ith value, by that I mean, and I runs to the total size. So you can just do it, treat it as a single array and then access each element. That also you can do if that is easier to see. Okay.
Like I tried it, like accessing the single elements of the 2D array, but when I did that, when I like when I let's assume that I assign a pointer to the
Mhm.
zeroth element, and I just assign its value to some third pointer, and then I increment the first pointer. So then the first pointer whole together goes to the second element, and there's no record for the first element. Like if I increment the pointer one by one, then it will eventually go from elephant to chocolate. But I have then no record of elephant. Like then I can't access um, I can't access the elements of elephants and chocolate at the same time to swap it.
Okay.
I,
So
I
like
don't
what
know if I am able to
kind
explain it.
sure, sure. I think I'm getting what you're saying. So you want to okay, so the question okay, so okay, one thing I'm just thinking of it is like thinking out loud. I have not understood the question. I'll ask you the question, but you can think you can actually
Yes,
have two
yes.
pointers now. Yeah. You can have two
Okay,
pointers pointing
yes.
to different addresses.
Yes.
Yeah. So
Yes.
actually, what is the question here? As in, so you have given an array, elephant, chocolate, which contains these phrases like elephant, chocolate, so on.
Yes.
What do you want to do here with this? As in, what is the question? So it was you want to swap strings, yes, but then
Oh,
do you
yes.
have to swap characters like elephant is appearing first, then chocolate will appear first, and then elephant, uh, or almond
I
appear
had
first?
to arrange it in ascending order, so I just wanted to sort it. But while I was doing the question, the thing is that like I don't know. I'm so sorry that I can't explain it. What was the problem that we were facing? I have my friend who couldn't join. He is in the same course, but he couldn't join. And
Okay.
maybe he could explain it better. So
Yeah, that's
can we discuss it in the next class?
yeah, yeah, that's fine. That's absolutely okay.
Okay, okay.
You
We
can
will
ask
think
me
about
this.
it and we'll find a way
Yeah.
to what?
Sure. Hello.
Hello?
Yeah. Hi. Yeah. Sorry. Go ahead.
Okay, okay.
Yeah. You can ask me this next class also. So, as far as I understand,
Okay.
you want to swap characters, and one thing I can suggest to you is you have actually given a perfectly valid pointer ARR itself. So you can just use ARR plus I, like ARR plus I, and run that I to 0 to size, as in 0 to 200 or something, and then dereference that,
Yes.
and then have two pointers, and then
Okay,
keep swapping.
I would try this. I would try this.
Yeah. I mean, it is fine, as in it depends how you want to see a 2D array. It's absolutely okay to see a ND array as a matrix with like n dimensions or something. I normally just see them as 1D array because it's easier for me to. I mean, that's what I like to do. So that's again, it's a preference. It's nothing to.
I think it's a problem of perspection because our teacher told us that you have only studied about integer arrays, and the way integer arrays works are simpler and character
Yeah,
arrays are a bit complex. So
I
we
see.
can't map the elements. So like if we try to do a question on them, we can't see us doing like how should we call it, how should we replace it, or how should we do any action on them.
Okay, okay, I see what you're saying. Yeah, right. Okay, I see what you're getting. Right. Okay. All right. I think you can ask this and like have a. I mean, whatever input I've given, you can probably try those things and let me know next time. Sure.
Yes, for sure.
Sure. Okay.
Thank you.
Awesome. Yeah. Thanks. Okay. Question. Why are you making X universal variable then assigning them memory? Why are we typecasting it in again in class? Oh yeah, we're not exactly typecasting. So thing is, we have to sort of define it. So yeah, I mean that's what is little tricky here. Uh, it's sort of like the reason syntax the whole program is. Uh, So I have to sort of define like as in this is declaration. I have to instantiate or define actually define X only after I define my class. right? And I set some value or not. Let's go with setting the value. Why not? Now the thing is, here I have to define it as integer also because it's just what it is. Yeah, I don't know how to explain it, but the reason is it is still X, but in the namespace of my class. Okay. And it is an integer, as in because I'm declaring a new space for it, but it is already defined. I understand that this is seems a bit roundabout that if I've defined it to be integer already with static, if I why can't I just declare it with name and equals 0? I'm not entirely sure why also, because ideally, yes, that because the type is already defined, to define equal to 0 probably would have been okay. But I think the only reason here is that, like, this is again my interpretation. The only reason here is that because it was defined earlier, but actual memory allocation was not done. Hence, we define with the data type. Okay. I'm sorry, this is the closest I can explain this. This is again how the C++ was defined, like the standard was defined to handle this. Okay. Yeah. And again, this
Is
is
a static memory like const because it doesn't change the value of it. Like if we one declare it as 0 and the second time when we get into void get, it assigned it value as 15. So
right.
after that it won't for B it won't change it again to 15. It
No,
will be 20.
no, that's the thing. It's not a const. Const means value cannot be changed. Okay. Here it is not const. Actually, you can have a const static, but then it doesn't make any sense if you want to change it. So const, always remember, whenever you say const qualifier on any variable, it means that value cannot be changed. Okay. But here it is not const. Let's keep that aside. Here it is static. And what is static? It is shared by different objects. Now, the thing is, because I use get, it sets x to be 15. I print it, it increments by 5, so 20. Print will get 20. When I call b get, it sets again x to 15. And now here's the kicker. The same x gets to be set as 15. So previously the value was 20, now it is 15. So when you do print, okay, then you get 20 again. So that's what you see. So 20 and 20. Static just means that a value is shared. Okay. That is what here the static means. Okay. It's not const. Const means something cannot be changed. Okay. Yeah. Okay. Awesome. Any other questions? Why to make it static? Yes, you can make it public and access it anywhere, but sometimes we want a variable. Okay. Think about this. So let's say I have an object, okay, which has X as public. I have another object which will have X as public. But the problem here is that those two X's are different. Okay. So if I change X of A, B will have no idea that X was changed of for A. Now, this is again what I'm getting at is it depends on a problem. Yes, you might not even use it, but the let's think of it from the behavior of the static. So because now X is shared between A and B, let's say a third object C itself I created some time later, and that changes X. Because X is static for the class, my class, that gets changed for all of them. And for that is definitely one thing to remember. Second thing is memory. Because static gets allocated memory once for all of them, you actually save on memory. So that's another reason you want it to be static. You don't, again, the reason, I'll repeat this. Whenever you create an object, A or B, all of the memory inside it gets created for all variables, unless they're static. Okay, keep that aside. Public member, private members, like variables, all of them gets the memory. The functions, they also get memory. All of them, all of these get their own memory for every object. So sometimes you do not want to allocate more memory, as if you want to save on memory and have a variable shared by different objects. That's when you use that. Okay, awesome. Yes, I think. Okay, I hope that makes it clear. Okay, awesome. Okay, moving on. Any further questions? Okay, moving on. Let me make another uh, file to explain this another concept. So we'll start with, oh, sorry, my bad. Hash include IOStream, then hash include. I'll have strings. Okay. Let me define a class called data. Then inside this, I'll have a string. We'll call it ID underscore. Okay. Define the rest of things as public. So again, this is private. I'll have a constructor of data, which takes const standard string. Okay, as reference, why not? Let's call it ID. Okay. I'll define, usually it's the opposite. Might as well write it that way. Why not? Usually it's the opposite. So define ID as ID underscore. Then, yeah, have the body print, sorry, construct ID underscore, sorry, all right, ID. Okay. Have a just a default destructor. Okay. I mean, as in that's it. But the reason to have this destructor is I want to print a statement that it actually reached there. Okay. We'll see why I'm right giving this example. Okay. Then I'll define my class. And let's define two static members. Okay. Both are data, as in this data type. Okay. Let's call it D1. Mm, yeah. And this as D2. Like have two data types. And then because these are static, I have to what do you call that? As in define like these are declared. I have to define them. So data type of D1 data. Okay. Then it's in the namespace of my class. So that and then D1. Okay. And it takes values as strings, right? So let's call it um, first object. Okay. So D1, I'll treat it as something of first object, and D2 has something of second object. Okay, and then we'll have empty int main. Reason for that is this program actually, I mean, main has to be there, so hence I'm putting it. I don't need to actually call any object or create or anything to see this example in action. Because it gets compiled, it automatically constructor and destructor and all those things will happen, because anybody can tell why. Because, okay, I'll say that. Because I have a my class, right? It already has the data. So the construct, so when this gets compiled, its constructor will get called. Okay. Now let's compile and see. We're calling it globally. Uh, we haven't actually, I mean, yeah, in a way, yeah, you can think like we're calling it globally. Yeah. More of like a, we are just compiling it. And because this data is sort of, how do I put it? Gets created is as in the member variable member variables of my class, which are these two D1 and D2. Because they get created, their constructor gets called. Okay, that's essentially what's happening. Now static. Let's compile. So let's start. Yeah, so that output is more clear. So printing this, what we see is D1 gets D1 has passed, it has been passed the first object, and D2 has been passed second object. Okay. So when its constructor gets called, so we see its construct first object. Okay. Construct second object, that's what gets called. And then we see destruct. Okay. So the thing about static is uh, it exists till the program, as in here for in this case, it will be till the end of the program. So when finally the program ends, then the objects get destroyed. First the second object, then the first object. Okay. More specifically, D1 is defined as in the definition. The okay, how to put, so this is instantiation, as in actually giving memory and all that. But the actual declaration was done here in line 13 and 14. First D1 was declared, then D2 was declared. Okay. So you can actually repeat and see second gets destroyed first, because second, this is the one which goes out of scope first, and then this one which gets out of scope first, if I tell it in air quotes or something. Okay. Now this is important because D1 gets allocated first, so as in constructed, then D2 gets constructed. Okay. What I'm trying to get at here is there is an order to which uh, static members get yeah. Sorry if it's get bit confusing, but what I'm trying to get at here is there is an order in which static members get allocated memory, and that order is defined by in the order in which they're actually declared. What I mean is, let's say I switch these two, then let's see the output again. Okay, so let's keep it first and second. So we see first and second. Okay, but if I switch these two, first constructed, second constructed, destroyed second, first constructed. See this gets reversed. So D2 gets created first, okay, and then D1 gets created. But when yeah, the question. Okay, just give me a second. Yes. Okay. So overload the constructor and call all of the which one will destroy first and last. Yeah. So what I'm getting at here is the there is an order to which as in when you define something as static, uh, it depends which gets as in it is actually sort of defined which gets destroyed first or later. That's what I'm getting at. You can overload it. I'm not saying you cannot, but this is just to have the constructor and destructor both are written such that I can actually see the output, as in which one is actually getting constructed and which one is actually getting destructed. Okay. So if I switch them, this is the output. Okay. But let's say let's see the original output first. Again. So construct, then first and second, and then second and third destruct. So this was output for this code. But let's say I switch now static data D2 and then D1. Okay. Now let's see. So previously I had first, second, second, first. Now it is first, second, second, first. Okay. So what I'm trying to get at here is the order in which you define or declare your static members. That is uh, that does not uh, affect which gets constructed first or second. Okay. So I'll just maybe make a note. So maybe this would have been more clear. Sorry about that. So originally this was the order, okay, and we print it. So we see first gets created, also second gets created, and then destruction. Second gets destroyed first, and then first gets destroyed. Okay, because there is an order to which it is actually getting created. Because this code this line 17 and 18 are the lines which actually allocate memory. But declaration lines which actually declare that those variables, I switch them. Then what I see is no change. It's exactly the same. So what I'm trying to get at here is, I'm sorry if it was confusing at first. Uh, what I'm trying to get at here is the order in which you actually declare the static members, that is immaterial, to the order in which you're actually defining them. What matters is actually the definition, the declaration, the instantiation actually. Okay. Now, as we saw before, if I switch this order, then my output changes. The second is actually constructed first, then D1 is constructed, hence the construction line changes. And as it reaches the end, first this object gets destroyed and then this second object, as in it goes in the reverse order, sort of. Okay, that's a question. Uh, is it like if we have three static members, 1, 2, 3, then destructor will be 3, 2, 1? Um, Again, that depends on how the declaration was done. Actually, I guess we can do that. Why not? Let's create a 3, okay? As we saw, the order in which we declare doesn't matter, but let's have an order in which we actually instantiate them. Okay, and I'll call this third. Okay, D2, D1, D3. Okay. This I'm just maybe declare this way and say that. Now let's see this output. Okay, so the order in which I instantiate them is second, first, and third. That is the order in which we see the construction. Great, awesome. But the destruction goes the reverse order. Okay, awesome. Yeah. Yeah, okay. Uh, I hope this is clear now. So, uh, the, so the summary of this whole exercise is the order in which you actually declare, that does not matter. The order in which you actually construct them is what gives the memory, right? So because of creating and reallocating, as in the constructor gets called, the destructor gets called. There is an order in which when, sorry, there's an order in which when that happens for these static objects, That's what creates this order of construct or destruct and so on. Okay, awesome. Uh, okay, then I guess we can go. Any questions other than this? Okay, I guess we can move to the next concept called the this operator. And hash includes something. It's called with IOStream. Then I'll define my class. Okay. So let's say I have public variables, integer x, y. Okay. Then a function void. I call it for takes inputs a and b. Then what this does is uh, it sets a to x. Okay. So I can do it this way: x equal to a, and then y equals to b. As in, this function basically sets the internal variables, and these are public, yes. So you can do it outside also, but let's say I'll remove this to here. Okay, so these are private members, and this function sets them these internal or private members to a and b. Okay, and that's it, I guess. Yeah. Okay, now let's define it main. Okay. I'll define my class, some object a, not a, I'll call it obj. Okay, then let me define some values called p and q. Let's say this is 7, and q is 10. So I can then call the function defined under this class. Defined under this class. Sorry. Yes, yeah. So defined under the class my class. Okay, has function func, and object is the member of this class as defined. So it will take p and q, and the code is simple. It will set 7 and 10, as in it makes a it's a pass by value, right? So it makes a copy to a and b, sets the values of a and b to x and y, which are internal members of x and y of my class. So for this object, it's x and y gets set. Okay, so simple code where mm, then if we print. Okay, for this example, uh, to get the values, I'll make them public again. So x, so we call it just x, then access it, and then enter name. Similarly, I'll do y. Okay, I think we know the output, what will happen, but just to for completeness. So 7 and 10. So now it sets x and y to be 7 and 10, like what we saw. But I can do it in a slightly different way. Okay, so let's say they were private. Okay, and I want to access x, but using something called sorry, maybe not, let me not erase it. Comment. I'll access x using something called this operator. So you can think this to be the pointer of this object itself. So for this object, there is a address which actually it has basically when you define some any variable like this, it will have some memory. It gets allocated some memory. This object itself will have some memory. So accessing that like basically this address, think of this as in this THIS keyword. So it's defined by C++. It enables you to access that classes, whichever object may it be, that guy's pointer. So think of this as in I'll put it under quotes to say this is by the inside the class itself. Yeah. So this as my class pointer. Okay. And then I'll set it to I'll set that value to x as an x value to be a. Okay. I cannot do this if they are private, but let's see. Uh, should work. Yeah. So essentially, what happened was they were private, and here too, I can't print them. I'll make them public and print it, but I can access the variables x and y using this operator inside the function, inside the class itself. Okay. So this is just to show that in classes, in C++ classes, you have an inbuilt uh, pointer as my class pointer. Like let's say this is my class. So this you can treat as a my class pointer data type and access members using an arrow operator. Okay. So again, important thing to access functions. So this is a function, right? So access functions or member variables, you use dot because the data type is my class of object. If it was my class pointer like this, let's say, so you would have done object arrow. That's all. It's just a syntax difference. So it just says that object is of some data type, custom data type class. Okay. It's it's um it is pointing to a it's a pointer of some class. To access its function, I use the arrow. That's all. That's the only difference. Okay. I hope this is clear. So here I because these are private, I can't print them, but you can take my word that as in you can accept that this here using this and arrow and x equals to a does exactly the same as setting x equal to a. Because for a class, internal member variables are accessible. You don't actually need to do this, but this is another just an example to show you can access x also. Okay. Right. So questions. That's private. Yes, it is. It is read only. It is not read only because it's not const. And then can you explain line 20? Line 20. Yeah. So line 20. Oh, when I say the arrow, okay. What I'm saying is if I had declared not object, this object, this is the data type. You can think of custom data types as classes are also custom data types like integer, double, and so on. So my class is a data type. So similar to how you have integer pointers, double pointers, and so on, you can have class pointers. So it's something like this. Okay. And but the extra thing you have to do is when accessing members of that class. So this is a class pointer, but it still points to some class, right? So to access the members of that class, you just have to change the syntax to arrow. Essentially, these two are doing the same thing as in now here object is a my class pointer. I'm accessing its function and passing P and Q. Okay. So this will also do the same thing. I print. Oh yeah, this will throw error because oh yeah, because this is yeah. Maybe let's just do this way. Should not. Oh. Sorry, my bad. The slight thing about pointers is that you have to declare, you can't just expect to instantiate objects like this. So this, okay, so there's a big difference. I'm sorry, I should say that, definitely mention that. So when you declare my class with an object, here the constructor gets called, it gets instantiated, all the data and memory and everything gets allocated. Okay. Now here's the difference. When you do this, it just tells the program that I'll have an object which stores an address of data type my class pointer. That's it. Again, back to the basics. Object here is just, it's not a full-fledged my class object. It is just a variable which stores an address. That's it. We have to actually declare like we have to actually instantiate the class using the new operator. Okay, that is separate. But the point is, uh, here the memory has not been allocated. Here the memory was allocated. Okay, but let's say the memory was allocated. To access the function, you have to use the arrow operator. That's all. That's what I'm saying. Okay, I'll make a note. Use new operator.
Sir, is it
To
like using new operator like we declare in Java and C sharp?
Mhm. Oh,
We
I
have to use it new operator like that only. So my
I'm not
class, object,
right.
new my class, then constructor.
Yeah. I'm not familiar with C plus C sharp or Java, but I'm pretty sure the intention with the word new is that allocate memory. Okay. The nice thing about classes like this, okay, let's say if you define classes, allocation of memory is done automatically by the constructor. As in, there'll be a constructor gets called, all this memory gets allocated for intermediate variables, function, everything. So that happens automatically. There are reasons one can still do my class like pointer object and then do a new. It is valid. There are codes which, I mean, there are use cases for it. But again, one has to remember that this just stores an address. It is currently completely empty. We have to create the new object of the class, like construct and everything, and store that pointer to this object. That's all.
And sir, if we are like in void function, we are using that arrow symbol
Hmm.
to access private data. So we can
Yeah.
edit the private data, no? We can
Yes.
use it in other
Yeah.
classes also. So like data is not secure, no? Anybody can access the private from anywhere.
Yes. This is a just to show an example that if you use this and um, you can access private members. Yes. So anytime a public member gets called, okay, function, what it does is uh, sort of should be hidden from the actual program. As in, what I mean to say is, let's say I call this function. Okay, this is a good example. I can make real and imaginary private. I just want to know the norm. I do not, let's say I know let's say I get this C1 from somewhere, C2 from somewhere, C3 from somewhere. I do not have any access, any way to know what is the real part, what is the imaginary part. But if the norm is public, it has access to the private members. Here it is public, but for a second, if you imagine these are private members, it can access real and imaginary. It can return me the norm. Okay, that's what a norm this function should do. What I mean by that is now, if you write a getter or setter function, then yes, you can access the private members, which let's say you do not want to happen, then you do not write a getter or setter function. Now, the other thing to like be clear here is, here I was accessing a private member. Yes, I did. I actually don't need to use this also because X is accessible by the function. Yes. If you change variables, you have to be very careful what the function actually does. As in, I can write a function to change intermember variables. Yes. And because it is intended to do that, when you will call the function, it will do that. So it's on the programmer actually to not give that functionality to change private member variables if it doesn't want to, or make them const so that they never get changed. Again, it depends on what the uh, uh, programmer wants the user to do, or the whoever uses that program to do.
Okay, let's say like private data int x is private. So can we access the memory location of int x in our main class
Int memory.
using pointer
Um,
directly without using that?
you can't actually. So the idea is that this private member should be hidden from outside. So
But
you
we are
can't.
accessing it here.
But there's a difference, right? This is access inside the class.
Yeah. So okay, understood. Yeah, yeah.
Yeah, yeah,
Hmm.
yeah. You can. I mean, I can access X also. I'm just doing a roundabout way of accessing X here. That's all. I'm using the this operator, then go using the arrow operation arrow to access X.
Yeah, okay, yes. Understood.
Yeah,
Thank you.
yeah. Okay. Okay. Any further questions? Okay. This question is about destructor. Is it this program?
No, sir. Like I know that much destructor is used for like destroying memory after constructor.
Mhm.
So in real world example, why will we use like destructor? So
Oh,
let's
okay.
say if a program is running, okay, so
Hmm.
the program is running, we need that memory now. Let's say we
Hmm.
are assigning some value to our using constructor to our
Hmm.
data members. So
Right.
during the program is running, we need that value. So if destructor will happen, then that memory will be like cleaned.
Yeah.
So why we need destructor?
No, no, that's the thing. Like there is a default destructor. There is sort of a default, default constructor. There is a default destructor. As in, it. No, no. So, yeah, okay. You're asking why we need a destructor. Okay. So when you actually allocate memory using new, you have to delete. That's what I told. Okay. The reason for that is when a program ends, there is no guarantee that that memory was freed. The So every program has an associated process. Okay, so I'm going build a little more outside of programming now. So there is an associated process attached to a program which runs on your CPU cores or something. All this is handled by your operating system.
Operating, yeah.
Yeah. Now, thing is, the operating system sees that a program ended, sure, but the program had some memory allocated, but never freed. So when you actually free up or delete a pointer or something, let's talk in context of pointers. So when you allocate memory, malloc or new or something, if you don't delete it or don't free it, the operating system still says that that memory is still being used by the program, even if the program has ended.
Okay, okay. Yeah.
So one has to actually manually always delete or free any pointers. And the great thing about classes is that, and actually this is a very beautiful thing about C++, just using scopes. Okay, you can just start allocation at like let's here in this case, right? The constructor gets called as soon as the data gets instantiated. So this is, in a way, you can think like the whole program is a scope now. So first scope, so done. And then when main ends, okay, so the final bracket ends. So then the destructor gets called. So the memory for this object, whatever complicated thing, yeah, whatever complicated thing we did, it gets destroyed. So automatic memory management is sort of inbuilt into C++ if you use them properly using scopes. It's something nice in Python where they have different ways of keeping track of memory of objects and all. C++ has its own way, and it works. I feel this very nice way of keeping track of things. Yeah.
So there's another question. So like
Yeah.
destructor doesn't take any parameters or return any value.
It doesn't. I
It
mean, it's up to you. You can you can um, have a body for it to do something or not. Normally, we don't have any. Doesn't take any value. Yeah.
so why we need to make it like public? It will automatically
Oh yeah,
in
there is a default. Yes, there is a default destructor. This I made it to so that I can print something. So to see where actually something got, which one got destroyed first. That's all.
Okay. So my question is like if we make it private, then it will automatically happening inside the class only, no? So why we need to make it public?
Oh
It
no, no,
would
no. So that is so these are still functions in a way. You can think like these are functions. They need to be called outside the function, outside the object. They won't be called inside the object. They need to be called outside the object. So they have to be public.
okay.
So here
Yeah.
when I call D2, it is outside the well, in a way, outside the object, outside region. This region is outside.
Yes.
So yeah.
Okay, sir. Thank you.
Yeah. Okay. Copy and move construct. I think we'll take that in the next class. Yeah. Anyway, that is sort of what I was going to cover next week. So yeah. Again, as I always end the class with this, do practice this like programming. So all this concept that you learn, you get better at it when you Um, oh no, no, it's I've not covered it yet. Yeah. So what I'm saying is all these concepts you actually have better grasp and you understand them better when you actually program them. So the more you the more you practice, the more you write them and see the output, the clearer things become. So for example, this right, um, just write the code. You'll see if I change the code this way, how does my output get affected? That gives you more clarity actually, right? So yeah, that's more or less it. Okay, we'll end the class. I think that should be okay. Yeah, we'll end the class. See you guys next week. If you have questions, you can post in the forum or ask me next week also. So yeah, and happy coding.
Thank you, sir.
Yeah, thank you. Thank you. Hope you
Thank
enjoyed
you,
today.
sir.
Yeah, thank you. Thank you.